Today we're going to look at our study guide over our data analysis unit. This is going to be a DCA and it's going to be our last one, so it's number 6. The date of your test will be Wednesday. That will be, it's going to be April 21st. All right, so we are going to answer these questions. Please try to do this on your own, and then the ones that you are having trouble with or you have questions about, then watch the video and solve them, or watch the video to check your work after you have completed the ones that you know how to do. Number 1, place an X in the box next to the situation that is an example of variability. Okay, so variability means that we want different answers for each student or each person that we ask. Number of class periods you have each day. That is not an example because every student will have the same answer. Number of students that did not do their homework. That is going to be a good example of variability because you're going to get a different number of students who didn't do their homework in each class. Number of 6th grade teachers at the school. That is not a good example because we have all the same teachers and they're not going to be different. So the only one that's an example of variability would be the number of students that did not do their homework. Number 2, we are going to label the data as symmetrical, skewed, or uniform. Symmetrical means that we can draw a line down the middle and it's going to be equal or a mirror image of each other on both sides. Skewed is going to be kind of like a teeter-totter or a balance where the data is going to lean more towards one side or the other. Uniform is where we can draw a straight line across the data and it is going to be all equal all the way across. So graph A is going to be an example of skewed. It is leaning more towards the right-hand side. Graph B, this is going to be symmetrical, or you can just say symmetric. Graph C, this is going to be skewed. Graph D would also be symmetric or symmetrical. Graph E, this is the only one that is uniform. Number 3, identify the outlier in the set of data below. Remember, outlier is going to be a number that is much larger or much smaller than the rest of your data. So looking at my data, I have 7, 12, 17, 5, and 47. So 47 is much larger than the rest of your data. So 47 would be considered your outlier. Number 4, identify the statements as true or false using the histogram. So remember, the histogram is going to be in intervals. So if you look at the bottom, the intervals is going to be the amount of money, the salary that each employee is going to make. So we are starting with 0 to 10, and this is in thousands, okay? And then we have 11 to 21,000, and then on the side, that's the number of employees who actually make that amount. All right, so more people make over 44,000 than less. So let's just go ahead and put the numbers of each one above the bars. So the number of people who make 0 to 10, that is about 50 because it's halfway between 0 and 100. The number of people who make 11 to 21,000, this is 300 people. 22 to 32,000, that's a little bit more than 250 people, so I'm just going to say that that's probably closer to 275 people. 33 to 43,000 is 400 people. 44 to 54,000, that is halfway between 500 and 600, so I'm going to call this one 550 people. 55 to 65,000, that is between 400 and 500, so 450 people. 66 to 76,000, that is more than halfway between 200 and 300. So this looks very similar to the 22 to 32,000. So I'm going to say that this is 275. All right, so over 44,000. We are going to take the 550. We're looking at this one, and this one. 450, 275. Let's add them together. So we have around 1,275 people. Now let's look at less than that. So I get around 1,025. So more people make over 44,000 than less. That statement would be true. More people make over 66,000 than less than 22,000. All right, so 66,000, that is going to be 275. Less than 22,000. So less than 22,000, that would be 300 and the 50 right there, so 350. And then this one's 275, so this one is going to be false. All right, let's go on to number 5. That is over here on the right-hand side. Number 5, what would happen to the mean of the data if the outlier were removed? Okay, so you can think of this a couple of different ways. You can actually calculate the mean. You're going to add all of your numbers together and then divide by how many numbers you added, which would be 1, 2, 3, 4, 5, 6. Then take out the outlier. So the outlier in this situation would be the 2. Okay, you could take that out and then you could calculate the mean again and then see what is going to happen. Is it going to stay the same? Is it going to increase? Is it going to decrease? Or is it going to double? All right, now knowing that this number here is just a 2, and so that's a very small number. However, when we have to divide 1, 2, 3, 4, 5, 6, we're dividing by 6 instead of dividing it by 5. So when we divide by a bigger number, we're going to get smaller, okay, because the 2 is so small. When we're dividing by 5, our number is going to be larger. So in this situation, our number would increase. So you could actually calculate and do the math if you wanted to prove that it would indefinitely increase. Number 6, what is the mean of the dot plot below? All right, so mean means average, and remember that mean is mean to you because it's going to make you do a lot of work. Mean is where we're going to have to add our numbers together, and then we have to divide by the numbers, the amount of numbers that we added. All right, my suggestion is going to be go ahead and write down all of your numbers. So we have 1, 0, 1, 2, 3. We have 3 1s, 1, 2, 3, 4. We have 4 2s. We have 2 3s, 1 4, and 1 6. All right, let me make sure that I have all of my numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so now let's add these together. We have 6 and 4 make 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. We have 12 numbers that we added together. Yes, you are going to go ahead and count the 0 because that's a number that you added. And so we're going to divide by 12. 12 goes into 27 2 times. 2 times 12 is 24. Subtract. You get 3. go ahead and let's add a decimal point and a 0. Raise your decimal point up. Bring your 0 down. 12 goes into 30 2 times. 2 times 12 is 24. Subtract. You get 6. Go ahead and add another 0. Bring that down. 12 goes into 60 5 times. And we finally get a remainder of 0. So our mean or average of the data is 2 and 25/100ths. Number 7, find the median. All right, so median means middle. The one thing that you have to remember on this one is you have to line up your numbers least to greatest before you start crossing them out. All right, so let's go ahead and do that. We have 2. We have 9. Cross your numbers out once you write them down to make sure that you have all of your numbers. We have 10. We have 11, 13, 15, and 25. All right, so let's see how many numbers we actually have. 1, 2, 3, 4, 5, 6, 7. So that's a good thing because we have an odd number in our data. So that means we are going to have a middle number. If we had an even amount of data, then we would have 2 numbers in the middle. And that's where we would have to add those 2 numbers together and divide by 2 to find the middle number. But when you have an odd set of numbers, you are going to have exactly 1 that is in the middle. So our median for this data is 11. Number 8. Describe the best relationship between the median and the mean of the data below. Well, in order to describe this one, we're going to have to actually calculate the mean and the median. So let's go ahead and line them up, least to greatest, so we can find the median. We have 1, 2, 3, 4, and 5. All right, I'm going to go ahead and add them together before I start crossing them out, so that way I can calculate my mean. We have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5 numbers. 15 divided by 5 is 3. So that is your mean. The median, let me change my color, is the middle, and that is going to be 3. This is the median. All right, A says the mean is greater than the median. The mean is greater than the median. No. The mean is less than the median. No, because they're both the same, right? C, the mean and median are both the same. So C is correct. The median is 3 and the mean is 3. Number 9. Which data set has the largest range? All right, so range is going to be where we take our greatest number minus our least number, and that is going to equal our range. Now, we're not talking about the interquartile range. We're just talking about the regular range. All right, so set A, we have 8 minus 1 equals 7. Set B, just because these are big numbers, go ahead and calculate it just to make sure. So our biggest number here is 987. Our smallest number is 983. 7 minus 3 is 4, and 8 minus 8 is 0, 9 minus 9 is 0. So set B is 4, set A is 7. So which one has the largest range? Set A. Even though they're smaller numbers, we have the largest range in set A. Number 10. What is the range of the dot plot below? All right, so we're looking at the dot that is on the biggest number, which is 5. And the dot that's on the smallest number, which is 1, 5 minus 1 is our range, which is 4. All right, let's go to page 2. Number 11. A data set has a median of 54, a lower quartile of Q1, which is 15, and upper quartile, Q3, of 75. What is the interquartile range? All right, so we're talking about a box plot here, okay? We don't actually have to draw one. What we have to do is remember what interquartile range is. And remember, when you draw that box, your interquartile range, the end of the box is your Q3, the beginning of the box is Q1. So we want to know the range that's between or inside the box. So we're going to take Q3, which is 75, minus Q1, which is 15. And that is going to equal our IQR. 75 minus 15 gives me an IQR of 60. Number 12. Mr. Rowland recorded 7 test scores as follows. So here's his 7 test scores. He made the following box plot from the data. So there's your box plot. 2 more students took the test and made a 73 and 92 on the test. Okay, so I'm just going to go ahead and write these out. So 70, 73. So here's another student. Let me make that a different color. So we're adding this one in here. So we have 75, 80, 83, 90. All right, I have to add in the other score of 92. Okay, and let's get our last test score on there, which is 95. Okay, so 2 more students took the test and made a 73 and 92. So I have represented that in our data. Which of the following best describes how the additional data will change the box plot? Okay, so let's go ahead and label the box plot with what we know. So this is going to be our least number, okay, which is our minimum. This one is our maximum. So that's going to be our greatest. Okay, the dot that's inside the box, that is your median, middle number. And starting the box is Q1, ending the box is Q3. Okay, so let's see how the extra set of test scores will change the box plot. A says the Q1 will decrease. Okay, well, we're going to have to go ahead and just go ahead and calculate these. So first of all, let's find the median. So we're going to cross our numbers out to find the middle number. Okay, so the median looks like it's going to stay the same. This is our median, which is 80. All right, our Q1, that is going to be the middle number of the lower half. So we're going to cross these out. Okay, so the Q1 is going to be 73. Our Q3 is the middle number of the upper half. And so this is Q3. Right between 90 and 92 would be 91. Okay, so now let's look back at our answer choices. The Q1 will decrease. Q1 is going to stay the same. So that's not correct. The range will increase. Okay, range is going to be where we're taking our greatest minus our least. So on the original box plot, we have 95 minus 70, which gives us 25. If we look at our data that has the two test scores added in, our greatest number and our least number does not change, and so that is going to stay the same. The median, letter C, the median will decrease. The median here is 80, and in our new one, it is also 80, so that's not correct. The Q3 will increase. Q3 on the original is 90. Q3 on my new one is 91. So D is correct. Number 13, last one. Which statement is true based on the dot plots above? The range of set 2 is smaller than set 1. All right, so set 2 we have, this is 47. So 47 minus, this is 33. So this one is 14. Let's look at set 1. So this largest number is 43. Our smallest number, 38. That is going to give us 5. The range of set 2 is smaller than set 1. No, that is incorrect. B, the mode of set 1 is higher than set 2. Okay, remember that mode means most. So on set 1, our mode is 40, because 40 appears 4 times. Set 2, our mode is 40, because it appears 2 times, and that's still the most that it's occurred. Okay, so B is not true. C, the median of set 2 is larger than set 1. Okay, so the median, we have to find the middle number. Median means middle. Okay, so on this one, for the median, I'm going to just cross them out on the graphs themselves. You could write down your numbers and then cross them out if you wanted to do that as well. Okay, I'm going to start with set 1. We're going to cross out our smallest number, our biggest number. And then we're going to go to the next one, next one, next one, next one, and so on, like that. Okay, we have 2 numbers that are in the middle, but that's okay because they're both the same numbers. So our median for set 1 is 40. All right, so let's do the same thing on set 2. Start with our smallest number and our largest number and cross them out. All right, once again, we have 2 numbers in the middle, but they're both the same, and so that makes it easy on us. So our median for this one is 40. So C says the median of set 2 is larger than set 1. That is not true because they're both equal. D says the median and the mode of sets 1 and 2 are equivalent, and that is correct. So that is true. That's letter D. Okay, guys, data is not difficult, okay, but it does take you a while to calculate everything that they're asking you to. So on your test, please take your time. Please show your work and prove that your answers are correct. And if you have any questions on your study guide, go back, watch the video, or message your teacher and ask those questions.